Hello, everyone. I'm Greg Weaver. Welcome to the Audio Analyst. Pardon me. Today, in my fourth conversation with the remarkable Andrew Jones, he brings us up to speed on his move to and time with ELAC America, starting in February of 2015. Now, his time at ELAC has represented yet another especially fertile period for Andrew, wherein he has created a remarkable number of exceptionally performing yet extremely cost-effective loudspeaker models, from the debuts in 3 iterations now, the original, the 2.0, and the reference, through the uni-fis, the Adantes, the Carinas, and even a series of innovative and remarkable in-wall products. His ability to create affordable loudspeakers that repeatedly set the standard for exceptional performance and value cannot be disputed. So, hey, let's get to it. Here we go.
Hello, everybody. We're back again with our favorite guy, Andrew Jones. He's been really popular the last couple of weeks here, and he's been so gracious to spend so much time over so much of his history with us. I've gotten some great feedback from people. It's been a blast. I personally have enjoyed the hell out of it, so I hope everybody else has. But today we're going to pick up with him leaving TAD, where we were last episode, and move into the ELAC experience. So, Andrew, why don't you pick up with the move? It was February of 2015 when you moved into ELAC,
Yes.
And how did that happen?
Yeah, lots more stories from me. I can't get enough of myself. I can't get enough of myself.
Neither can we, by the way.
Yeah, so TAD Pioneer and then transitioned to ELAC. It was an interesting time. Pioneer was changing, and so I thought I would change as well. And I got the chance to basically start something new, although it might not seem like it. In a way it was, because ELAC is a long-established speaker company and hi-fi company, started back in 1926 in Germany. And long storied history. I knew of them. I'd see them whenever I went over to the Munich show, and they intrigued me. But they started life making acoustic instruments. So ELAC stands for electroacoustic, and they were doing underwater acoustics and marine acoustics originally.
Wow.
Sonar type things, yeah. And then in the late 40s, they transitioned from sonar, I wonder why, to hi-fi. And
the war was over, so...
the war was over. So they switched to hi-fi and started with turntables, and became the 3rd largest turntable manufacturer in the world, behind Jewel and Garrard. So they had a lot of success here in the States with those turntables. They were called the Benjamin Miracord turntables. And whenever I normally mention ELAC to people, they go, oh, the turntables, the Benjamin Miracord. But although they had huge success with that, towards the end of the 70s and obviously by early 80s, because of the introduction of CD, that kind of killed that type of turntable business. And so they switched to doing speakers. And some great product, but for some reason they never broke through really with that in the US. So well known throughout Europe and Asia, but not in the US. And at the time when I was looking to do something, they were looking to expand and try and get the US market. So we all hatched a plan that we would start an autonomous, mostly design group here in the US to, I guess, build up the name of ELAC in the US, but doing it not simply by another group trying to import the speakers that hadn't been really successful over here, but by starting anew and designing new ranges of speakers. The thing is, they'd always been a mid-high-end company.
Right.
I was able to do mid-high-end, obviously, but also develop this niche for doing good-sounding, really affordable speakers. And we thought, if we try and work on a flagship, it's going to take years before we establish the ELAC name. But if I do something that everybody's been asking me, Andrew, when are you going to do something a bit more expensive than that line of Pioneer speakers? People are asking for it. Why not give them what they want? And we'd already proven that the fear, presumably within the ELAC, the group of ELAC guys in Germany, just like TAD had this fear that you're designing an $80,000 speaker and now you're going to develop almost an $80 speaker and put your name on it. Won't that damage the reputation of TAD? And it didn't.
No.
I explained that it actually enhanced it because people don't all of a sudden go out and buy an $80,000 speaker.
Not normally.
Some do, but most don't.
No.
And they start somewhere. And the idea that I pay attention to the people who are starting something, starting to get into the hobby, that captivated the audience. And so this is just the next step on that ladder. And so we thought, why don't we just start at around the $250 price point? And it started actually at $229 for the 5-inch bookshelf.
These were the debuts that came out first, yes?
The debuts, yes. So we started in February 2015 with an empty building and a conference table that Chris came with me from ELAC and ultimately a sales guy as well, Jim.
From
Credell.
Infinity, not ELAC.
From Pioneer.
Pioneer,
Let's get that
I'm
right.
sorry.
Yes.
Now, where was this? Was in California, yes?
So we were all together at the Pioneer facility in Long Beach. So we looked around for facilities in Southern California in that generalized area. I drew the short straw because what we ended up with was 40 miles south of where I live. For Chris, Chris found the facility and it was 5 minutes from his home. Gee, I wonder how that happened. But we got this building, we moved in, Chris found a conference table and 6 chairs on Craigslist, and that was it. That's what we started with. Started to draft up ideas for product, and I started to build out my measuring room and my lab, and by June we had a prototype of the 5-inch bookshelf, and that's what we launched at the show in LA, and that it just went off from there.
I'm
we
sure.
got such a good reaction to that launch, and I remember we decided to keep it simple for once, and I got just an all-in-one player amplifier system from Bel Canto. So it's basically one box. Plug your computer in if you want the inbuilt DAC, and a pair of speakers and stands. And I used one of the pieces of furniture that was already in the room to put everything, or put the electronics and computer on, to say this is simple but high performance, because the electronics were total $4,500 with a $230 speaker, but it was kind of say this is a different way of doing things, different way of building the system, and it's not an intrusive system. It's a small speaker with one box of electronics. This is the kind of thing that's possible, and it managed to get it sounding really. I literally walked into the show with 2 suitcases, one for the speakers, one for the stands and electronics. I've never been. It's like when you're selling headphones, you can go to a show just wearing the headphones around your neck and just walk around and have a desk, and it's very easy. You're not bringing in all this stuff. I mean, I did bring in room treatment, but the system itself was 2 suitcases, and that was the start. And in a remarkably short time, to have that prototype ready to go in June after moving into a new facility in February. And then we were shipping in about September, October, or selling. So,
that's amazing. I mean, the tool
Yeah.
up alone for building the drivers. I mean, because now ELAC, did they build the drivers in Germany and ship them? Were you building them here?
So for all of this, no, all China built.
Oh, okay.
But using the same factories that I'd had
Okay.
years and years of experience with, and with all the Pioneer stuff. So it meant we could get a good, quick start because we knew how to work together.
You had an established relationship with them, right? So
Exactly. Yes.
yeah, okay.
And the important thing with people, it's very political these days talking about China, and let's just keep that side out of it. But the idea of how do you start manufacturing in China? How do you know how to get the quality control? How do you know which factory to use? It's a minefield. If you haven't ever dealt with it, then you can go bad very quickly at a lot of cost. But I'd got years of experience working with this factory, so it meant I could get a very quick start on this product lineup. And as long as you design within the manufacturing capability and processes and jigs and fixtures that company is using, and you pick the right company, you can get remarkably consistent results. I was very careful at the beginning of that project to specify the tolerances I wanted to test to carefully, designing as much as I could the parts to be tolerance-free of worry, kind of.
Okay.
And once we started, you always got the process of as you hand building the first couple of samples, and I test them, and I build a few more, and they test a bit differently. There's a progression as you go along. But once you've got to manufacturing and you produce your large batch and establish what that's doing, you can stay within half or 3/4 of a dB across the whole range of the woofer
Really?
when you build and manufacture it right. And that's better than a lot of small-scale, high-end driver manufacturers achieve.
Sounds pretty reasonable to me.
Yes,
good
yes,
tolerance.
and especially for a speaker that's that price point.
Yeah.
So that gave us, we got the 5-inch version, the 6-inch version, the center channel, towers, and subwoofers, all of it. And the subwoofers were app controlled. So that's a lot of work that had to be done that first year.
I hadn't realized the subs had app control. Were they powered? They were powered then. If they
Powered,
had.
yes.
Yeah.
Yes.
I hadn't realized that. I thought they were passive for some reason.
No. And,
Oh, that's great.
app controlled, room EQ
Yeah.
built in. So it was very easy to use them, to set them up and use them, because you could do it all from your chair. You could blend it, adjust the blending to your main speakers by just playing music and turning these controls. Not having your children crawl around the back of the subwoofer and you go, turn it up a bit. Right? So it was
Right.
a stressful time, of course, launching something new, but also a fun time.
Yeah.
Whenever you start something new, you get fresh ideas and fresh impetus. It's not that you're stale, but there's just this sudden burst of enthusiasm. You always, after a while, get locked into all the other things you still have to take care of. And sometimes your ideas don't blossom as readily. You have to work more for them. But when you make drastic changes, you can suddenly go, oh, this is something I'd like to try. And that's what we were able to do.
Well, they were a very successful line, and that was the first line. And then we got the uni-fis, right? Which that was basically a still a very affordable product, but using a really sophisticated approach with the concentric driver.
Yes. Now that was a real challenge, because when we've done this, let's say the $250 price point for a bookshelf. What do we want to do as our next bookshelf? I don't want to just fill in just $100 increments.
Right.
We wanted to say, okay, what would we do for a $500 bookshelf? And when obviously when you're designing, you have to be mindful of what the competition is. You're mindful of what is it, what have they put into it, how could they afford to do that. There's also you measure it and see what its performance actually is. Say no more. But then you could listen to it. I don't really spend much time listening to competitors' products.
Sure.
I can tell a lot from listening, from measuring. I can't tell everything from measuring. I don't believe anyone can just measure a speaker and say this is how it will sound. You've got general guidelines of what measurements to make, what response curve you're going to aim for, how close you got to it. But it's always, there's so many awkward factors between the on-axis and the off-axis response and the rooms you're going to listen to it in, that the finer detail of what its sound is like is a mixed bag. So you really need to listen to it and listen with your prejudices, basically. Is that a sound I like? Because maybe you can't fix everything. Well, obviously you can't fix everything in a affordable speaker. So, I give it a cursory listen, but basically I've got my idea of what I want this flawed product to sound like. And so, I hope the marketing group isn't listening into this.
I'm sure they're not.
Yeah, they listened to it at work enough to me without having to follow me on videos. So, so beyond that, you then look at, okay, well, what is it? What are people doing at a $500 price point? Double the money to spend. Well, some of it is maybe going to go into the looks. Some of it is going to go into the driver engineering and the crossover engineering. And there'll be a split between how much extra you spend on the technology of it and the sound quality of it, and how much more you spend on the looks of it. And, the $250 is a vinyl cabinet, square box, flat-sided box. That's all you can really afford to do. I know we did a curved-sided box for that Pioneer speaker, but that was, many years later, totally off the cards as an affordable thing to do. So we looked, and everything was a nicer looking two-way speaker. Maybe the box is built better, there's a better cone material, maybe a more complex crossover, but on a cursory examination, if you're someone who's not really into hi-fi but wanting to buy something, and you're shown a $250 speaker and a $500 speaker, you'll go, yeah, it looks nicer, but why is it double? Because it kind of looks the same. And we didn't want to be in that position. Sure. And of course I want to do a concentric driver, because that's... You're
Andrew Jones, for goodness sake.
I'm Andrew Jones. And of course I want to do it as a three-way system. So we're talking about $500, and I'm going, well, I'd like kind of this 4-inch concentric driver and a 5-inch bass driver. And it's another of these situations. Are you kidding me? You think you can do all of that for that price point? But we worked at it. And the most difficult process in that development was the crossover, because obviously going to a better two-way, the crossover cost isn't necessarily that much more. The driver cost isn't hugely more. You can make it, but but three-way, you've now got 3 drive units, and one of them is a concentric. And when you're crossing over with a three-way system, I wanted to get the crossover point reasonably low, which is about 270 hertz, I think, from bass to mid. And that is a big, complex network. Yeah. The network filled the entire bottom of that cabinet, and huge inductors, big capacitors. That was almost its undoing because the initial cost estimates were just way off. So I had to both work on the factory to try and get the price structure I wanted, and at the same time work on the network and say, okay, where can I take cost out without drastically affecting performance? Did I specify the right inductance resistance ratio for that inductor? Because the lower you try and make the resistance of an inductor, the bigger and heavier you need, more and more copper, then you need a bigger core. Well, could I add some resistance in there to have thinner wire and still get the performance level I wanted? So it's those kind of things you work on. And we did it. We got the uni-fi at $500. So that was a sort of game changer there at that price point.
It really was. And to interrupt briefly, you were kind enough to help me buy a pair that we gave to a buddy of mine. I've been over to his house. He added a powered subwoofer later. I helped him get it dialed in a little bit. And Andrew, people have been in his house and thought it was a $7,000 or $8,000 speaker system. I mean, these things are $500. You knocked that one completely out of the park, and the concentric setup alone that you pulled it off at that price. I mean, it just speaks volumes to how clever you have to be to get it done, buddy. They're pretty impressive speaker. Now, they went the uni-fis. Now, the debuts on the 2.0 version. Did the uni-fis come out in a 2.0 yet?
Just, yeah, in the last few months they came out. Yeah.
And I had one of my viewers ask if we could identify the difference between the original and the 2.0 uni-fis. Is there, without giving away trade secrets, is it just minor overall improvements, or were there something specifically you were trying to do with the newer version?
Oh, it was. I'm willing to say minor in some respects.
Well,
there were touches like on the cabinet. We changed the vinyl.
Okay.
Just because the vinyl we had chosen, which was a metallic grain pattern, like brushed aluminum, that was rather vulnerable to, if you brushed against it too hard, it would leave a mark, and you couldn't get that out. So we wanted to make a more durable vinyl, stiffen up the cabinet a bit, put some extra bracing in.
Okay.
Change the tweeter, improve the tweeter. Change the surround on the mid-range because surrounds on a concentric driver are a very critical item because first of all they're going to disrupt the sound wave, so you want to get it low profile. And the shape I'd gone for originally, it was low profile, but it didn't give enough flex. It raised the resonant frequency of the driver up more than I really wanted it to. And so I was playing around with new shapes and new materials for that surround. And I changed the tweeter to an improved dome. And the woofer was probably the least changed of all. But still some changes. And then rework the crossover network because I felt balance-wise there were definitely improvements I could make to the speaker.
Okay.
It was a bit mid-range forward. A lot of people liked that, but you either say mid-forward or treble down to some degree. So I wanted to play around with that and change it and open up the sound a bit more. And so that's what it ended up being. But we'd done the debut 2.0 before that. It was once we introduced the debut 2.0, the first question is then, so when are you going to do a uni-fi 2.0?
Of course.
I keep saying, haven't I released enough speakers over those 6 years at ELAC
Apparently
to date? It seemed, I look back and think, what on earth was I doing? Well, I obviously wasn't going on vacation.
I'm sure of that. Oh God. No, I don't know. So, anything else you wanna discuss it with those, or before we move on? Because the next line is one that I want to talk about. I'm very fond of the Adante line, but
the
if
Adante,
there's-
yes.
yeah, that was next. No,
Yes, just as, I mean, other than saying, well, we had the debut, the uni-fi debut 2.0, then okay, uni-fi 2.0, then the debut reference, which we can get back to.
oh,
shortly.
I had missed those. I'm sorry, that's right. I had asked you about
missed
that
my
before
debut
we
reference.
started the video. I'd asked you about that. What was the difference there? I mean, externally, the first thing you noticed was the veneer was different. It was they either had like a walnut or an oak or kind of finish. But what else was different about the reference?
So it was to say, okay, now instead of aiming for those very affordable price points, what if we raise the price up to about $600 for a two-way bookshelf? So we're back into what we didn't do originally, except we still have a uni-fi as a step up if that's the direction you want to go.
Okay.
But one of the consequences of aiming for the lowest price is because the industrial design is compromised, in terms of choice of the covering, the colors, the whatever. And all the previous speakers are all built on steel chassis, and steel chassis can ring. And so we wanted to say, what would I do as the ultimate expression of basically that approach, or that version of a speaker? How far can I take it? And without going silly. So we decided to, because none of this is expensive high-end.
Right.
When we get back to, well, for what do I get for my $500 two-way? Well, you can then go, well, what do I get for a $5,000 two-way? How can that? We got a better quality vinyl, which sounds an oxymoron, but is beautiful embossed vinyl that you could mistake for real wood floors. Just like if you're redoing your house and putting down wood floors, these days those vinyl versions, engineered vinyl flooring, you're hard pushed to know whether it's real or not, real wood veneer or not. And so some of these vinyls are like that. And then we said, let's have a satin painted front and two color schemes, black front with the walnut or white front with that oak. And they look very nice. And then we were able to upgrade the chassis to cast chassis, and also machining a bright trim ring line around it. Then a brand new tweeter. So this was the tweeter basically from the Adante, or very close to it.
Oh, wow. Okay.
Everything I'd put into designing that, I used that to design a version of it to put into debut reference. And then once again, improve the bracing and go to a slot vent, front mounted slot vent.
Okay.
For getting better bass dynamics. So lots of changes there, both in the looks and the engineering of it. And
anything particularly different about the dividing network, or was that just?
Yeah, more complex. About 3 extra components in there to fix some issues that I'd had all along. And it's the worry for me, at least, when I'm designing those systems is, okay, I've got debut 1, and it was very successful. Debut 2, I've got to improve it. But what if the reason people liked the debut 1 was the particular flaws it had that just matched into their system, or matched what you need when you're building an inexpensive system? What constitutes better? Not just saying that, well, if I make it different and call it better, that's one thing. But if I honestly believe I've engineered it to be better, but it's still not going to, obviously it's not going to sound the same as the original.
Right.
So will those people who liked the original all agree that they like the new one and they like it better. Now you'll obviously get some people who say, no, you know, I don't like what Andrew did with those new ones. I prefer the old ones. Yeah, okay, some people will say that. But the vast majority, thankfully, agreed that it was better. But then, not only have I got to that step, it's now, well, let's do a debut reference.
Yes.
And that's got to be better still. Like, oh! So that's where your insecurities just ping, 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 pop up, and you go, how do I do this? How do I? But that's life. That's trying to, you know, whenever you're working on something, you face those issues, and so that was it.
Has the debut reference line been fairly successful? I don't know much about it, to be honest. I've seen it, but I've not. I think they certainly. I mean, for the guy with $250 to spend, you know, or I don't know how many want to go up to 500 right away, but you know, we talked in one of the other videos that I work in a factory, and guys that, you know, $250 is a lot of money for somebody to spend on a pair of speakers. But I've had 3 guys that work on the floor buy those speakers, and they all think they're fabulous. So the step up to the reference has the sell-through been pretty good on those? I mean, I don't know much about them.
Yes, it has, but
good.
The biggest question we get is, because of the way and the timing and how costs change and tariffs have made everything more expensive, what we were originally planning to do is slightly different than what we ended up with. And what we ended up with was the new price, the price of the uni-fi had to go up because of tariffs. In engineering the debut reference, we knew what those tariffs are, so we can work within that, still put it out at more expensive than, you know, relative to what the debut 2.0 was. It's going to be more expensive.
Sure.
But it now got it almost the same price as the uni-fi, the original uni-fi. And so it's now okay, sort of in the same price point, $500 to $600. Which one do I go for? Yeah. And that was just, you know, that debut reference price point just made it, we're competing almost directly with ourselves. And so, which one should I buy? That took a lot of thinking, how do I answer that?
Yeah, that's interesting. Question. I hadn't looked at it that way.
Yeah, but it's not sort of unusual if you look at examples with cars. You buy a BMW, maybe a 3 Series, and then you step up to the 4 or the 5. And you can find models in both ranges, a really fully loaded 3 and a basic version of a 5, let's say, or a 4. And they're around the same price point. They don't do the same things.
Not at all.
But they meet the differing needs of people.
Sure.
And, you know, there are people who prefer a standard, let's say, 2-way system to a concentric 3-way. So you've got that. Well, please, sir, tell me what your preferences are, and I'll point you towards one or the other. You could say they're comparable in sound quality, but in different ways, because they each have different things they can do. You know, the debut reference is a 6-inch. The uni-fi 2.0 is a 5-inch. Now, it's got some advantage by being a 3-way, but it still loses out ultimately in how loud at low frequencies it can go, because a 6-inch is a bigger cone area with a bit more movement to it. So if you're just about getting a lot of low bass, I'd steer you towards the debut reference.
Yeah.
If that's not what you're trying to do, then uni-fi.
Well, the auto reference is a good analogy, because it makes a lot of sense. I think it really shows what you're trying to do with the different speakers. Now, I really do want to talk about a Dante because I really like those. I can't remember whether it was Axpona, maybe Rocky Mountain, where I saw you show those the first time. But I mean, you know, and the thing that was cool, you didn't notice immediately. Well, you wouldn't know immediately, but they had, you know, we saw the concentric driver and 3 8-inch aluminum. They were aluminum cones on the front.
Yes.
8-inch. But then when we come into the room and you're telling your stories and playing music for us, we find out that those 8s are passive radiators with 3 active 6.5-inch aluminum drivers inside the cabinet. And when I first heard, you know, I think I don't know if it was Phase Research or Polk or somebody that was, you know, when I thought of passive radiators, that was a very old, clunky philosophy. It was a weird kind of way of doing it compared to what you were doing with that. And when I heard you tell that story, I mean, it was a complete. Did it come from the coupled cavity idea? Where did you get the idea to do this? I think it's a crazy speaker, man. It was really good.
So, yes, in some manner, it came from coupled cavity because it's basically a form of coupled cavity. And when we started to design it, I wanted to explore different ways of doing things. And I hadn't worked on coupled cavity for years. You know,
I mean, Kef, you didn't do that anywhere else, did you? After Kef?
No, I didn't. No, not at Pioneer, not at TAD. So I thought I want to try something different and try and get this in work. And when I considered the last range of speakers that I'd started on at Kef, I'd expanded from the version of the coupled cavity that we used in the 104.2 into something called interport coupled cavity. So your base loading is all about how much can I get out for a given size of box. You know, we discussed this before, box size, bandwidth, efficiency. And what tricks will increase that efficiency constant so I can just do a bit more. So coupled cavity was one of those techniques. The other way was imagine a regular coupled cavity is you've got a speaker in a closed box behind it. So it's a closed box speaker. Now you put a box on the front that's got a vent.
Right.
That's basically the configuration. And it does something where it turns it into a band pass speaker and just gives you that bit better efficiency. Now you can also say, well, what happened if I took a vented box, a front vent speaker, and put a box over the front of that? So now I've got a box that's being driven by both the driver and the vent. So that was interport. It gives you a further advantage, but it ups the complexity of building the system and tuning the system to perform correctly, and plays havoc with your ability to design the crossover network. It's definitely one of those instances where you go, I just wish everyone would accept active speakers. It would make my life so much easier. So I had that thought in mind, and I thought, you know, one of the problems with coupled cavity type systems is the vent that you put on it, and this will inform you of what I'm going to say later. When you're tuning a bass reflex speaker, the tuning frequency of that vent is basically the low frequency cutoff point of the speaker. So if you want to go down to 40 hertz, you basically tune the vent with that size of cabinet to 40 hertz. And the trick with vents is I don't want too much airflow or too high a velocity of airflow through the vent, because it'll start laminar flow and it'll start chuffing.
You'll hear the
but the problem is the lower you go down in frequency, the longer the vent needs to be in order to get that tuning frequency, or the bigger the box needs to be. So let's say we fix the box, we fix the driver size. What size vent do we need? Well, the largest diameter you can get away with. But that means every time you increase the diameter to maintain tuning frequency, you've got to make it longer. And at some point, it doesn't fit in the box. Sure. This is one of the problems with doing bass reflex or vented box subwoofers, because they're tuned really low.
Right.
And you're still wanting relatively small boxes these days. So it's tricky. What happens with that front vent on a couple cavity is it's tuned to the high frequency cutoff point. So that sounds as though it should now make it easy, because you can make it large and short. And if you think about the vent, that front vent on the 1042, it's something like a 4-inch diameter vent, but with a curvature across its whole length, and it's about that deep.
It was pretty shallow.
Yeah, but now it's sort of at higher frequencies. It's an open hole into the box and any box resonance and stuff like that. So that's a downside of it. So I thought, well, technically, there's sort of no difference in, let's say, go back to subwoofers. There's sort of no difference between a vent and a passive radiator acoustically, given that you meet certain conditions. The air in a vent is a mass of air. It's a slug of air that pushes back and forth and tunes with the stiffness, the compliance of the air, just like a Helmholtz blowing over a bottle. The neck is a mass of air, the bottle volume is volume, and it has a tuning frequency. You can substitute a physical mass for the air mass, and that's what a vent is.
Passive radiator.
Vent's on right, but that's what a passive radiator is. So, but because it's a physical mass, it's got to be held in place, right? So it's got a surround on it, maybe 2 surrounds, a spider and a surround. So it'll stay where it is,
keep it
and
linear,
be restored, right? And then it can just move back and forth. Now, because it can't move physically as far as air in a vent would do, you make it larger diameter. So it's either typically at least as large as the woofer you're going to be using.
Right.
And because it's now large, it has to have a very high physical mass to get the same acoustic mass as the vent does. Now that's a bit complex, but basically it means that it can weigh 100 grams or more. But its effective acoustic mass is the same as the effective acoustic mass of the air in the vent. So from a system point of view, people get this idea that, passive radiators are really heavy. You've got to move this weight, so it's going to be slow and ponderous. It's nonsense. As far as the system sees it, it's exactly the same amount of mass as it's trying to move, because it's got more force applied because it's over a larger area. So acoustically it's identical. But you now have got this suspension to hold it physically in place, and you have to make sure that that suspension frequency, so the free air resonance of that thing on its own, is very low, 10, 20 hertz. Make it too low and it's just waving about in the wind. So you don't want to do that. So to a first degree, they are identical. So I thought, what if instead of having a passive radiator for my, I keep mixing those terms.
It's all right. But anyway.
So if I want to put a passive radiator on the front, I've got to look at, what characteristics does that need to have? Obviously, it has to have the same acoustic mass as that front vent, but it's a lot lower mass. So whereas with a passive radiator in a regular subwoofer, your problem is you've got to add mass. So you put these steel discs on it because you want quite a heavy mass. In a couple cavity scheme that I used, it has to be a very light mass because it's tuning at least 2 octaves higher, maybe 3 or 4 octaves higher than a typical passive radiator. And the difference also is that in a regular system, at the tuning frequency, the driver almost stops moving and the vent or passive radiator takes up the rest of the movement. So you can say they're both operating in parallel in a way. They're both directly addressing the air to the outside and to the inside of the cabinet. But if you think of the coupled cavity, the drive unit was inside the box. And it was, the air had to pass through the vent, not be in parallel with the vent, but pass through the vent to push on the air in the vent and make the sound.
Okay.
In this case, the drive unit buried inside is pushing on the air, which pushes on the passive radiator to radiate. So they're acoustically in series. And to get all the tuning frequencies right, it turns out that passive radiator has to be quite light.
Okay.
And so when I started doing this analysis, my first thought was, can I make it light enough? And one of the tricks was to make it larger, because things scale. You know how certain animals, if you can't make a big version of an animal because size, your volume and density and mass don't scale all in the same way. Sure. So you can't have a big mouse. It would collapse on its feet and bones would break and all this kind of stuff. So a large passive radiator, larger than the actual drive unit, seemed the way to go, that I could physically get the light weight that I needed. And it was still a challenge to get all that tuning right. And you've got an internal vent, an external passive radiator, you've got the drive unit, you've got two cavities. That's a lot of things to play with to get the tuning right. And I thought I
can't imagine the mathematics involved.
It's kind of, I thought I knew what I was doing. And I apparently, when I started work on it, no, I didn't. And at points I was panicking. We'll actually manage to do this.
How long did they take to develop?
Too long, according to my company. A year and a half, something like that. They were a stunning
success, buddy. I mean, I was blown away with their dynamic capability. Mm-hmm. I mean, I'm not used to. I mean, this was a completely new idea for a passive radiator for me. And when you demonstrated them at that show, I was like, good God, they were what, about 5,000 a pair? The front the
towers, yes.
The towers, yeah. Man, anyway, go ahead.
In one way, the sound of it reminded me of the KEF 1042, in that the 1042 was efficient. It didn't go down maybe as low as you might expect for a speaker of that size. And I think the Adante was the same thing the bookshelf did. It went down low, but the tower, because it was very physically imposing, at times people didn't think it had the extended bass. If I saw one common critique from reviews, it wasn't as extended as they thought it would have for that size of cabinet, but they liked the dynamics that reproduction had.
Clearly. And the speed. I mean, they were... Now, was it terribly inefficient, or was it more efficient to do it that way? I mean, I would think... My first thought is that, using a driver to push air and move another driver might not be as efficient as just running a driver, but what was it actually like?
Well, that was the trick. That was the hint when I said the driving in series. It means over some frequency range, that mass is pushing another mass, and it's in series. So sort of the overall mass goes up, which means you have to take mass out of the drive unit or add BL. So that was one of the factors in all of the how to design this system. I did not have a full mathematical synthesis process for that. When you look at complex systems, you can analyze the system and say, this system mathematically does this. Then, to be useful, you want to say, if I need it to do that, what do I do? What calculations do I apply to make it do that? Analysis on its own is not sufficient. You need the reverse, you need the synthesis. Otherwise, you're guessing how to get from one to the other.
You brought this up in one of our earlier episodes, the difference between analysis and synthesis.
Yes. So, in fact, because Laurie came up with those mathematics, to do the synthesis of a couple cavity, but they didn't apply to what I was doing.
Right.
I'd added complexity. So I always work from an equivalent acoustic circuit. So any acoustic system can be modeled as a combination of each mass, compliance, and resistance can be modeled as inductance, capacitance, and resistance. And you put them together in a circuit, and that represents what it's going to do. So I came up with my first version of that, and I also built a prototype speaker, and then I tried to match that modeled circuit to what the speaker was telling me it did. And I could kind of get a reasonable agreement. So then, okay, now let's change this equivalent circuit until I get that and build it. Well, I didn't get that. I got now the other. So my model wasn't quite right. So
right.
That's research, and it sort of shouldn't be part of the product development cycle. But as I say, I thought I knew what I was doing, and clearly I didn't. So,
well, I thought they were pretty successful.
Yeah, I mean, I got there in the end, and I also applied some tricks in the crossover to help me. But it was a race to the finish, let's say, to get it done. So those things happen from time to time.
Now we talked a little bit earlier that they're no longer available. That series of products ELAC doesn't offer anymore. And you mentioned, and I want you to explain what you felt the reason was, because I thought it made a lot of sense. Please.
Well, you can't guarantee that everything is successful.
Sure.
And decisions you make that you think will work don't always pan out. It doesn't mean it's a bad product. It could be a bad fit for the market.
Right.
And especially that tower, it was a big imposing speaker, but didn't go down. This is why it reminded me of the 1042. It didn't go down as low as a lot of people might expect from that size of tower speaker. It also was very sensitive to system setup and what the equipment was that was driving it. You had to get it right. It reminded me also of my original TAD speaker, the Model 1. Very dynamic, very revealing. You sat down and listened to it and go, wow, I've not heard this kind of thing before. Because it was the Berlin concentric driver. But after a while you go, and I in my mind, it separates into two things. The speaker, that when I sit and listen to it, it tells me what the sound is. Or the system that you sit and listen to it, and it tells you what the music is.
Okay, I get it now.
There's a certain class of audiophile speaker that is listen to me. Not listen to the music, listen to me. Listen to what I do to the music. But it's this dynamic, very detailed. You can hear everything that's going on, but you're listening with your head rather than your heart. And Model 1 was like that. When I did the TAD reference one, I'd kind of realized that that's good as it is and viable because a lot of people listen to those kind of systems. But for me, it wasn't what I was looking for. I wanted something that gave it to you all well ordered, but in a more relaxed presentation.
Okay. Yeah.
And I think the Adante could do that, partnered with the right equipment.
Yeah.
But partnered with the wrong equipment, the intent.
You feel it was a little more particular about setup and
absolutely,
once
yes.
it used. So
and we're used to that in the high end.
Yeah.
But as you come down in price, it's got to be more adaptable, let's say. And I'm trying to give great value for money. And the driving concept of doing that speaker is not just a good speaker for a great price, but an entry-level high-end speaker for a good price.
Yeah.
It meant my intention was you put it into a high-end system, and what you didn't have to spend on the speaker, you can spend on the rest of the system.
Yep.
But so very often it was put into systems that were not of the
beneath
right
its capability.
match, beneath its capability, yes.
Yeah.
So, and it's such a big cabinet as well. Everybody likes slim cabinets. So the market for big speakers in those price point areas was diminishing. So I think that contributed to it. We never had, always good, well reviewed.
Yeah. Yeah.
And and of course, as soon as we basically get it discontinued, everyone's wanting to buy it.
Of course. Yeah. Of course. It's always how it works, right?
Yes.
So my guess is that Karina came next.
I think so. Yeah, roundabouts that.
Okay.
It's only. I mean, we're talking about 5.5 years with all these different systems, so it's. I can't remember exactly which
Probably a blur,
one came out when, but the next step was to do the Karina, because people are asking me things all the time about what you're going to do next, and I'd love to see you do something like this, and I'd love you to do something like that, and you have to be careful of, in a way, of listening to that too much, because because one person asked doesn't mean everybody else agreed with that.
Yeah.
And so I, in my thinking of what comes next, and also because of being ELAC, and certainly from a point of view of ELAC Germany, they were, let's say, one of the pioneers in the marketplace for folded ribbon tweeters.
They call it the Jet, right?
They call it Jet. They
is
call
it
it
trademarked or patented or anything like that?
Yeah, it's called Jet Emission Tweeter. So it's Jet or JE Tweeter.
CES show. What the heck? I mean, come on.
Yes, exactly. So Oscar Heil invented it, and so there was a Heil air motion transformer manufactured here in the States for the longest time, and up until I believe ELAC introduced their version, which is quite a different size and construction, but basically the same principle.
Yeah.
It was
it's
the
just
first
a folded
one.
ribbon tweeter, right? I mean,
it's a folded ribbon tweeter,
yeah.
And they manufacture it, or that version. When they started, they were manufacturing it fully in house, and still the Jet 6, I think we're up to now, is manufactured fully in house in Germany. So that was one of their main marketing efforts for the last 20 or 30 years.
Yeah.
That they pretty much 100% use that technology. And when I joined ELAC, one of the first questions I would be asked from people who knew ELAC and knew the Jet tweeter, so Andrew, when are you going to do a folded ribbon tweeter? And my excuse always, in one sense, was I'm trying to do the affordable stuff. I can't afford that tweeter. So I was able to kind of bypass the question. But in the Karina, we wanted jointly between ourselves and Germany, because there's still the German design group designing speakers, was to update a couple of the, let's say, long in the tooth ranges that they were selling. And so we decided that for speed of development, we would have Germany work on one of those series and I'd work on the other.
Okay.
And that's what became Karina. So this was my first time really working with the folded ribbon. I'd looked at them through the years. I'd measured a couple of them through the years, but I'd never seriously sat down and go, okay, now what do I really have to do? I have to understand what I think the sound is, what the measurements are, how I would use it, in what kind of system. How do I get to that point? And
it's a completely different approach from a dome, right? I mean,
oh yes, it is. But it's now. I said I don't listen to the competition. Well, I did for that. The competition was Germany's products. So I started evaluating that tweeter and getting to getting to know you and understand you. And it was a fascinating project. It does sound different from a dome. It does perform very differently. In the earlier days, you would say a clear advantage of a folded ribbon is it goes out much higher than any soft dome tweeter, and many of the metal dome tweeters. I mean, some of the metal dome tweeters obviously they have the big resonance at 25k, so they don't really go out high. Pure ribbons go out high, but they're very fragile, because Pioneer or TAD had the PT9 or RT9. It was a true ribbon made of beryllium, and it went out literally to 100k, a little 1/4 inch wide ribbon. So what I found was the most difficult part of working with it was the low frequency range.
How low does it go? I mean,
2.5k for the version I was using.
Okay.
Not many of them. See, with a folded ribbon, to get it to go low, you have to make it bigger or longer. So you see these 4-inch, 2-inch and 4-inch folded ribbon tweeters on the market. And I didn't want that, especially coming from doing concentric drivers, because now it's basically spaced a long way away from the woofer, because it's 4-inch long. And it's got a very limited vertical directivity. So it's huge difference between horizontal and vertical directivity. Now TH8X would go, yay, good, right, from what they wanted for cinema reproduction in the home. But it can be very troublesome for home. And when you look at all the ones that are about inch and a half, they struggle to get below 2.5k. And as they get there, they're not as clean as the bottom end of a dome tweeter. But they do go out high. But nowadays, we've got plenty of choices of even soft dome tweeters that go out to 40 or 50k. Directivity of the small folded ribbons is very good. It's very consistent off-axis. In the measured performance, they also nearly always have a bump above 10k. A lift up 3 or 4 dB often. If you don't do something with that, maybe that's what contributes and people like of the sound of a folded ribbon. But combined with the fact that it's got very wide directivity compared to a dome in that frequency range, it's something that you've got to be aware of and decide what you're going to do with it. And then the difficulty was, okay, so if I use this folded ribbon, I now need a woofer that will go up and meet it and still give me a couple of octaves, hopefully, before the first breakup mode in that cone, if I'm using a metal cone, so that I can keep out of trouble. So whereas with a normal system, with the bandwidth of the woofer and the bandwidth of the tweeter, at least I have some choice of where I put the crossover frequency. With this tweeter, is going,
it's going to
be 2.8k. I'm telling you, you can only use me at 2.8k, and that's what I end up doing. And then worked on how I was going to tame that top end. So I ended up with something that sounds very good, doesn't sound like a dome still.
Right.
And so you have to be aware of that. You know, if people want to think there's an Andrew sound, then this maybe is not.
That wasn't it.
In some part, it's not that Andrew sound. It's obviously an Andrew sound because I chose what to do with it, but it is distinctly different. But then the people who want folded ribbon sound are looking for something that is not a regular soft dome tweeter. And my goal is, if I'm going to give them something, at least I'm going to give my choice again of what I did with that technology to get to that sound. Because, you know, to some degree, just like, well, if I go from debut 1 to debut 2 to debut reference, they can't all sound identical, or else what's the point?
Right.
It's not just a cosmetic update. It's got to be informed by those choices I've made, but I've made choices that still satisfy me for what that particular sound is.
Right.
But it cannot be identical to the lower cost speaker, or a two-way cannot sound identical to a concentric three-way system. But they're all embodiments of the choices I made.
Right.
And so that this is a further one to meet the needs of ELAC as a whole.
Sure.
That has made a name for itself with folder room tweeters.
Now, just out of curiosity, if it's not giving away too much, you talked about that peak above 10K. With it, is it something you could address electronically, or did it have to be addressed mechanically?
Electronically.
I'm not asking for secrets, but I mean...
No, electronically. So the difficulty of addressing anything in a loudspeaker electronically is unlike applying EQ when you're doing a recording or something like that. They are one-dimensional systems. A speaker is a three-dimensional system, one input and an infinite number of outputs going in all different directions. And that's why we talk about tweeter directivity and waveguides and crossover point to merge the two together, and looking at on-axis and looking at off-axis response and getting the right balance between all of those. So you have to be careful thinking I can EQ out certain features or detriments of a drive unit, cone breakup. Although we do try and filter out some of the cone breakup, we don't get a perfect match over all angles because cone breakup is highly directional, and that big spike you might see in the top end of a woofer on axis will change drastically as you move off axis.
Right.
So you have to pick and choose what you're going to do. Just like the subwoofers, doing EQ on one subwoofer in a room will make some maybe improvements in one particular location to listen to, but it certainly won't improve it in the other locations, and it actually might make it worse.
Yeah.
In this case, because this hump had also got a wider directivity in that frequency range than the typical dome tweeters I've been using, then it made sense to attempt some form of electrical correction, because it needs it over a wide range of angles. And so that's what I was able to do.
Cool. Now, is the reason that, I guess, didn't these use something called a compound curvature woofer?
Yes, that was...
Was that because of the higher crossover point?
Because of the higher crossover point, I wanted to try and develop cone shapes that might help minimize some of that breakup mode at the higher frequency.
And this was designed to minimize breakup modes, yes?
Yeah.
Cool.
Yeah.
It
doesn't get rid of them, but it does help a bit. Yeah.
So what did you mean by compound curvature? I mean,
so
instead of being a constant shape, it was different at different locations, or?
Yeah, think of it first. It's a dished shape. It's not a cone with a dust cap.
Right.
So it's a continuous piece that's stamped into a dish, and then got a voice coil attached to the back of that cone. So when you take any shape, most dome tweeters, for example, are a simple radius. So they're part, if I took a sphere and sliced a bit off, when you're cutting your tomatoes or chopping off the top of your egg, that is the cap of a sphere.
Right.
And it's got a constant radius on a sphere. If it was on an ellipse like an egg, it would have you couldn't find an origin and draw a line through that surface and it would match it all.
Yeah.
So that's a compound curvature. And in 3 dimensions, if a cabinet is changing shape, like when B&W first brought out one of their speakers, the wood was not just curved from front to back, it was curved in both directions, and it was wood. That's difficult to do, that compound curvature. But even in 2 dimensions, you can have a compound curvature where the rate of change of shape is not constant.
Constant, yeah. That makes sense.
And with a dish, what I did was that dish had a simple radius, but then I flattened it, I curved it back on itself. Well, not literally back on itself, but I curved it so it reduced its rate of curvature towards the edge.
Okay.
So reasoning that this shape that is, I'm off camera, but undulating like that would add a bit of stiffness to control some of those high frequency modes.
Yeah. Now those were I'm trying to think where I heard those. Did they have? They also used that that really unique, cool downward firing port where
the downside
had the really kind of interesting angle on the bottom of the cabinets.
Yes.
Was that done out of necessity for anything else, or was it done as a different approach to doing a vented cabinet, or because it looked cool as hell, first of all.
Yeah,
it did look nice.
Yes, I thought it was a beautiful looking system.
Yeah.
And it also followed on tradition because the series it was replacing also had a down-firing port.
Oh, okay.
But it was done by having just a port on a flat bottom of the speaker, raised on nibs off of a base. So it kept a defined height of the vent above a surface, but it also radiated 360 degrees.
Okay.
So we wanted to follow basically that principle. But
I remember the 103
103
cheated. The stand was coupled right to the actual vent and continued the flare. So, but that's what it was weird.
Yeah.
But what I liked about these was, I mean, that angled look was pretty cool. And
yes, it was. And that was a cast aluminum base, so very sturdy. And see, when you're doing vents, I mentioned about keeping airflow down, so you need a long vent.
Right.
Front to back, the longest dimension in most speaker cabinets is top to bottom.
Right.
So narrowest is side to side, next is front to back typically, and next is height. If I want to put a long vent in, obviously the worst would be in the side because it's going to hit the other side of the cabinet.
Yeah.
The next is front to back.
I hadn't thought
the
about
best
that.
is top to bottom.
Yeah.
But not top to bottom, bottom to top. The last thing you want to do is put a vent in the top of the speaker.
Oh, yeah.
Especially if you've got kids, because it'll collect all their toys through the years. Yeah. That's where we put it there. And it somewhat ameliorates the effect of getting too close to the wall because it's not pointing, it's not the backmost part of the speaker that's ever going to be closest to the wall. It's further away and facing down under controlled conditions of how close to the surface it is. So it's more consistent for placement.
Yeah. It was a pretty successful sounding speaker.
Now
I don't remember how many different models were there of those?
It's the bookshelf, tower, and center channel.
Okay, so you could do like fronts, you could do rears, and a center channel. That was the way it was with most of the products, but I only think I saw the bookshelf. I don't think I saw the towers. So
one of the problems, this gets back to how many speakers there are. Even with the number of shows that people keep trying to put on, how do you show them all off? And it gets back to all the subwoofers. You say, I didn't know you had an app-controlled subwoofer. Yeah, our very first one.
I didn't know.
And ever since then, and we've developed the capability of those apps. But let's take the subwoofer, for instance. I'm trying to show just how much bass I can get out of a bookshelf speaker. Why would I demonstrate a subwoofer? Other than, let me just switch over for a track and show you the subwoofer. But typically, you never get the chance to do that because if you have a subwoofer in that same room,
People assume it's
People
on.
are going to think it's on,
Yeah.
and then you're going to have to prove it isn't.
Yeah.
I remember one show I was doing, California Audio Show up in San Francisco, and I'd got a tower computer thing to run as my music server, but I was using Debut or Uni-Fi or whatever the speakers were, and I got sick of this because people, is that a subwoofer? No, that's my computer. I did have a subwoofer. So you're playing that subwoofer? No, it's for show, because my marketing guys keep telling me, are you ever going to show a subwoofer? But I'm not playing it. And so by Sunday, I'd scrolled these notices on top of all. No, this is not a subwoofer, it's a computer. Yes, this is a subwoofer, but it's not playing.
That's funny.
Right.
That's so funny. God. No, I don't know. Have we overlooked any particular development that you want to talk about?
Well, there was a very cool in-wall subwoofer that I did. So, we addressed to some degree the custom install market, and our plan all along is to break more and more into that. So
sorry, it's the two-channel guy in me that overlooked all that. I'm sorry.
Exactly. Yes. But what we always said with ELAC is we're trying to offer something that meets needs that isn't being met.
Sure.
Either in price performance ratio or technology that helps you out. And by that I mean, I remember the words of, I might have said this in the previous one, Raymond Cook. You guys come up with solutions to, you engineers come up with solutions to problems people didn't know about or care about, right? And so let's be customer driven at least with what kind of technologies we introduce. So with this subwoofer, it was going to be an in-wall subwoofer, so a 10-inch subwoofer, and you have to design the drive unit to be very shallow because you've got about 3.5 inches plus a little spare for it to fit in a wall.
Yeah.
Because this is not new construction application, it's post-construction where you're coming in and you're cutting a hole in that wall and screwing something in. And you're not taking down the whole wall to build a cabinet between those studs and then repaint or repaper. So it's got to fit in just that hole.
Yeah.
And always the problem we were told with subwoofers is we don't know what space there is behind there. We don't know if there's a fire break or not. We don't know what volume we have behind the wall. So since basically that wall is the cabinet, how do you know what the low frequency performance of that speaker is going to be on a job site? And if you're putting dual subwoofers in, those two cavities could be different sizes.
Sure.
And so I was thinking about this and thinking, well, that sounds like a challenge that needs to be met. I can't sell an X-ray machine with every speaker. So what if we could the speaker tell me what size the effective enclosure is? Now, that is a very interesting thought process because remember I said I have these electroacoustic models of what the speaker is.
Sure.
Which is one of those inductors is the compliance of, well, let's say one of the capacitors in that circuit in the type of model I use. One capacitor represents the mass of the moving mass of the driver.
Okay.
One, the mass of the passive or the port. Inductors represent compliance. And so you've got an inductance that represents the stiffness of the driver itself. The other represents the stiffness of the box. So if I put my driver in any box, and especially if I simply put it in a vented box and run one frequency sweep, I can tell you what that inductor is.
Okay.
That represents not any combination of box and driver, just this is what the stiffness of the box is. From that, I can calculate and cross-check that it represents the volume of the box. So I'm thinking, so the driver knows what box size it's operating into. If I know the characteristics of the driver itself before I put it into a box, then I put it into the box, the way its resonant frequency changes when I put it into that closed box is a direct measure of the stiffness of the air and hence the size of the box behind it.
Sure.
All I need to do is track that change. And my first thought of the way to do it is if I can just measure the impedance curve in real time, and this subwoofer was going to have a controlling amplifier with it, with dedicated EQ, and it was going to have room EQ, so it got DSP in there to make measurements of the room.
Okay.
So I'm going, and it was also could do some current monitoring for safety protection. So I thought, can I turn that current monitoring into a method of measuring the impedance curve? Can this computer do a fit to that and then tell me what the size of the box is? So without ever getting a microphone out. And the scheme would work, but that current sensor wasn't adequate for the task, and it would have been involved to re-engineer all that. So I thought, well, what's another way of doing it? If I put the microphone in the near field of the woofer, I can measure the frequency response, and that's what I use as a guide for the room EQ. I'm EQing the room to match the near field response of the subwoofer, which is the response I designed it to have in a typical box subwoofer. And I realized that if I measure the near field of that woofer in a box, it'll have a certain frequency response. I just don't know what that is, because the whole point, I'm trying to do all this without needing a calibrated microphone. I'm using the microphone in the phone. I don't know what the response of the phone is. So it'll measure a curve, but I don't know how much of that curve is the driver and the wall or the microphone.
The microphone.
So I realized if I switch a high resistance, 100 ohms or so, in series with the driver, when I make that, what will happen is it will emphasize the response at the height of the impedance curve. It basically turns the speaker into a nice flat response into one that bumps up before it rolls off.
Okay.
That peak is at the resonant frequency of this combination.
And you can use that okay.
And I can then, in my design process, I measure, I get the characteristics of the equivalent circuit of that speaker, I put it into the equivalent circuit of a box, and I change the size of that box. And from my model with 100 ohms in series, I can tell you for every size of box what that impedance is, where the frequency of the peak is. And vice versa. So if I can just do a sweep and record the highest value it gets to, what frequency was the highest value, that means it's the resonant frequency. I can now calculate the size of the box. And that's what this app does. You run these sweeps and it says you've got a 57 litre box. That was a cool idea. That one we applied for patents on. So it's these kind of things. And now it knows it. Then it can map a new EQ based on that, so it gets it back to the reference response without needing any calibrated mic. I was some guy.
That's pretty cool. How much did that sell for? How much were those individual subs sell for?
I can't remember. $1,500 or something like that.
Well, that's not
like
that's
half the price of typical systems like that. Yeah.
That's pretty cool.
Well priced.
Yeah, it's very cool. It's very cool. I don't know. I like that idea. It's pretty sharp doing it that way. As soon as you saw me go, oh, I get it now. Yeah, it was pretty neat. So, so one of the things, you hit on a couple times in our conversations, analysis versus synthesis, and I think. By now, people get what that means and why research allows you to come up with synthesis after doing all the analysis, or sometimes it does anyway. One of the things that everybody knows what I think of your work. I think you're great. But I suspect that a big advantage to what you do on a regular basis versus some of the companies that build much more crazy exotic products is that you get the luxury, you know where you want to go, and you get the luxury of designing the drivers you want to fill that bill. That has to be an enormous asset for you. It has to be.
Yes.
Oh my God.
The more in one respect, you could say the more of the parts you can design, the more you can optimize the total system, and you're not reliant on other people.
Yeah.
Now, the downside of that is, are you as good at all those different tasks, right? We said with active speakers that, okay, Andrew knows about designing speakers. What does he know about designing amplifiers?
That's what Owen's for.
That's what my clone is for. After our previous conversation, I did discuss with him. So, although you were born first, I want to know, was your cell cloned from mine or the other way around? Because I want to establish a new priority date for the pair, for me. So, I forgot what I was saying now.
I'm sorry. I apologize.
Give me the question
Where
again.
were we talking about designing, building your own product, building your own
yes.
different items and
So
the challenges?
when it comes to an active speaker, I can say, well, I've got my brother, he can design electronics, or Peter Matnick, who's an established, well-respected electronics designer, etc. Now, one of the areas I can't do is the mechanical design of the speaker. I can't run the packages, I can't do 3D. I always feel I ought to learn, especially out of fun, because there's such cool things you can do. But again, like Laurie would be, if you can gather around you access to the right kinds of people who you can clearly see know how to do this and efficiently, but really well, then you don't have to do those parts. That's why it's a team. I know we keep joking about it, me, but basically you're always around a team that is supplying the expertise that you need. But I was my first exposure to being in the hi-fi industry at KEF was KEF made their own drivers. So right from the beginning, I got the ability, because I had the access, to go and tool up new cones and wind the voice coils and glue on the surrounds and play with drivers. And I think for a speaker engineer, access to being able to do that is extremely helpful.
Oh, yeah.
And it's not to say that there are a lot of really excellent drivers out there from different manufacturers that are way beyond in one respect, the quality level I've been doing recently, because I'm on, doing affordable speakers. But because I've had access to design drivers all these years, then even when it comes to a low cost one, I can directly choose the compromises I want in that drive unit and understand what impact, because when I get sample cones back or the surround, I can say, that's not working as I wanted. I need to change this profile, or I need to add a bit of mass on this part of the surround. And, that's helped these days by programs that help you calculate what a drive unit will do. But I also truly admire all these pure driver engineers who are designing some really great drive units these days.
Well, are there any projects coming up at ELAC, or any products that you're able to talk about that might be coming to us in the near future?
They're on hold right now, because I've spent so much time talking to you with these interviews.
Thank you, buddy. We have had a few people who have said an hour and a half. I'm like, and believe it or not, both of us, Andrew, can talk. I mean, you've seen me out in the real world too. But trying to keep these to a manageable time limit for people to watch them all has been a bit of a challenge. And I know we haven't been anywhere near exhaustive on some of these subjects, but I'm grateful for it. So,
no, I mean, there's always things coming up. One of them is very, very close, and the announcement is imminent.
Okay.
And from what I've been talking about, the ranges I've been developing, it might not be too much of a surprise. It's a long-awaited version of one of the speakers. Cool. Also been doing some really, really affordable speakers. That
$35 a pair. No, I'm joking.
Well, not quite, but it's.
I'm joking.
The ability to go down to low prices again, low prices.
Yeah.
With the right distribution channel, you can do something that is truly surprising. So there's some of that coming out soon as well.
Cool.
And I'm always thinking of possibilities of what I could do and how we, obviously we have to fit in with certain price points for a business. Sure. We have to fit in ideas because we want to show we're constantly thinking and pushing the limits. So there's that side of it, ideas floating around that every so often I dust off and try out again to see if I have a inspiration. So but there's some good stuff coming out.
Well, my friend, all I can say is keep it up because you constantly amaze us. I'm so looking forward to a day where you may be able to get to design $80,000 and $90,000 speakers again.
Me too.
Because that's where I play. That's my preferred area of play. So, Andrew, I can't thank you enough for everything. If anything you ever think of, you want to talk to us about again, you're welcome back on this channel anytime you want to come back.
All right, thank you. I appreciate it. It's been fun. I love these chats with you. Yeah.
I look, you're one of the more fun people to talk about. You're obviously one of the most seasoned and experienced and knowledgeable at what you do. So I am so grateful you've taken the time to share these stories with people. We really appreciate it, buddy. Till next time, take care.
Thanks, guys. Bye.
Bye-bye.
What a great conversation. I hope everyone appreciates just how gracious Andrew has been with his time, sharing all this amazing loudspeaker history, his personal experiences, and insights with us. Now, while today's conversation was the final chapter dealing with Andrew's career arc, there will be one more episode, one in which he shares more stories and tales, things that he covered while we were talking about his KEF days. And I think you'll enjoy some of this immensely. It's a lot of fun. I want to thank all my subscribers and suggest that if you have found merit or value in the information I'm sharing here, please subscribe. And don't forget to like and share links to your favorite episodes with your friends. And I love hearing from you, so be sure to leave your comments and questions. And you may support the channel using Patreon, Venmo, or PayPal, or even by securing display advertising at the Audio Analyst website. And links for all these options are provided in today's description section. As always, thank you for taking the time to drop by and visit today. Please stay safe and keep the music playing. Till next week, cheers.